So I imagine you can see the whiteboard from last time. So where we ended off, right?
Yeah.
Okay. So the one thing that we didn't have time to get to, so to finish solving this problem, so the key is that we go ahead and, as usual, and there's something in chat. Okay. So something that we're used to doing, which is for each of these firms, we find the profit maximizing quantity of the firm by setting marginal revenue equal to marginal cost. The only difference is we're working with the residual marginal revenue. And when we finish doing that, then we end up getting an expression that you'll note here at the very bottom. It still has the quantity of the other firm in the duopoly. And if we had multiple firms, say, and we don't study oligopoly theory deeply in this class. Again, if you took industrial organization, which is a good course and one I would recommend if you get a chance to, um, it would be a very similar expression, except for you would see if, for example, there were four firms. And typically, when you're studying oligopoly, four or fewer firms is usually considered an oligopoly. Once you get between like 4 and 8 firms, then the market power, which would be measured by the markup of price over marginal cost, quickly deteriorates. So that's kind of a nice result because you can look out into the wide world around us, and you could be concerned about a few firms dominating an industry, but without more information, you know that as long as you have at least 4 firms in the industry, that the outcome is going to be pretty competitive. Um, Again, unless there are other features that might cause you some concern, and they would talk about that industrial organization in more depth. But if the firms are otherwise symmetric, meaning that they have access to similar cost technology for production, then you'd get something that pretty quickly approximates a competitive equilibrium, which is a really nice result. But for our purposes, yeah, we would just add in additional terms here. If there were 4 firms, you, instead of seeing Q2, you would see Q3 and also Q4. And then you would see the Q1 for the output for firm 1. And again, as long as everything was linear, that one would enter this, what we call the residual marginal revenue from residual demand. So it's the leftover. And that's what residual means, is leftover. So the residual marginal revenue has the term that has the output for the firm that we're modeling, right? Its profit maximization decision comes in with a coefficient that's twice what the coefficient is for the residual demand itself. And then we just set it equal to the marginal cost for that firm. And we have this function that expresses the output of one of the firms in the duopoly in terms of the output of the other firm. And then we can go ahead and build on the analysis from there. But let's go ahead and do that. So I'm gonna go ahead and transcribe some of this information just so we have it available. This is a screenshot from the last time we were together. And so here's our new whiteboard. this is the relevant information. So we want the original demand. So I'll put demand. We had PB is equal to 260 minus 7Q. And then we note that we've got two firms that are contributing. So big Q is equal to Q1 plus Q2. And we use that to formulate this residual demand. And so I'm not going to go ahead and write all of the details, but I can. So I'll have P okay. And then we want the residual marginal revenue for firm one is going to be okay. And similarly, sort of in anticipation of what we're going to be doing, we can write the residual marginal revenue for firm two, and just notice that it's exactly the same equation. I'm just going to order things a little bit different. I'm not quite finished yet, so just hold on. So for these second terms here, so for firm one, that's going to be a 14. I can put in a little asterisk in there for to denote multiplication, to make sure there's no confusion. Okay. And then you probably remember we have the marginal costs for firm one, and that's going to be 4. So I'll write it lower case. And MC2 is equal to 5 times Q2. Okay. So then again, our main condition for both of these firms in this situation is that we want to look for their profit maximizing quantity. So we're going to be setting marginal revenue for firm one is equal to the marginal cost for firm one. And then we'll end up getting an output that looks like this. We're going to have Q1 is going to be equal to some function of the output choice of firm two. Okay. And we're going to be calling this and there are a couple of different names again. You could call it the best response function. If you call it the best response function, that's just kind of invoking the language that Nash used. So John Forbes Nash is the one who developed the Nash Equilibrium concept in game theory. And there are some other concepts in game theory too. You know, the Nash Equilibrium isn't the only one. It's just the the one that's most often discussed. Um, but you could call it a best response function because that's what Nash said that players in a game situation. And I guess I will stop just a little bit and say that when we're talking about a game, and let's just so I heard from you, Arslan, so I'll talk to you for a minute. How are you doing this morning?
I'm doing good. How are you, sir?
I'm pretty good. It's a beautiful day, and I just had my first cup of coffee, so I'm, things are looking pretty good. Um, Thanks for asking. So if I say to you that, in these small group situation, we model them as games. What does that mean to you? If you're going to try to differentiate that from, for example, a competitive equilibrium outcome, because normally that's our benchmark, right? Remember, the first fundamental welfare theorem is our North Star. It's, our center of the universe for direction. And so what would you say, is kind of key, and what distinguishes the way that economic actors, we often, in the abstract call them agents, um, what do economic agents do differently in a competitive environment as opposed to this small group game environment? Can you think about like how you would describe that?
Hmm. Um, well, to start with, when I hear game, I think experiment.
Okay, you think experiment. So draw that out a little bit for me. What do you mean by
hmm
experiment?
well, if it's a game, someone is playing it.
Right. Okay. Oh yeah. Okay. So you're probably thinking about like in experimental economics. You're right. So and I did a couple years ago. I did a sabbatical with Vernon Smith's group at Chapman, and so they have labs there at Chapman, and they pay people to play games with each other, and and they try to predict the outcome based on the types of things that we're doing in theory here with like the Nash equilibrium outcome for a game. And in fact, um, this is an aside, but Vernon's group received a grant of several $1 million from Singapore, and Singapore has a triopoly, three major electric power producers in their country, and they were trying to predict how this triopoly would price electricity, and what level of generation or capacity that they would supply for the country. For them, it was very important, right? Because they want to ensure that there's enough electricity and that the price of electricity is, I'll just, I'm doing little air quotes here, was reasonable to facilitate widespread economic growth. You can imagine you might be concerned if you were in a country dependent upon three major power producers, and they were all behaving like a cartel, right? And they were marking up the price of electricity um, to generate as much profit as they could for the three of them, acting in concert together, right? And that meant that the rest of your economy was suffering, right? That you might want to, build factories, or maybe you were going to build a new, one of the things that a lot of people don't realize is that a lot of the high tech industry is very dependent on having a reliable power supply. So you'll find that there are companies like Intel, for example, that will only locate chip factories in certain countries and in certain areas of countries where there's very, very little chance that they'll ever have a disruption in their power supply. Because when they're making silicone chips, if at any point in the manufacturing process their equipment is stopped, they literally will lose hundreds of millions of dollars in product almost instantly, because
Yeah, they're like created in those like extremely clean rooms, right? Super
yeah,
stable environment.
yeah, and not only that, but if you know anything about silicone chip manufacturing, it's they call it so silicone's a semiconductor, which means that sometimes it'll act like a resistor and sometimes it'll act like a conductor. So it has these wonderful properties when it's engineered right, that it can behave like switches, right? But they also lay down circuits within the silicone chip itself of various metals and things like that to create all of these circuits and switches in a very small area. And and they call that doping the silicone. And if you in the middle of the doping process you goof it up, and it's really neat too, because the chip comes out like have you ever seen like a uh, I don't know if your mom cooks or you cook, but like a block of butter.
Yeah.
Yeah, so they come out like these long blocks, and literally the CPU in your computer is one slice of that, and the circuits are running down the length of that bar, and they slice it, and that creates a chip. And so all those chips are the same, and they have the same pattern of circuits. And anyway, if you mess it up at any point, then all of those silicone wafers that you created are completely destroyed. And so if you have a minor disruption in power supply, minor change in the temperature or the doping or anything like that, you just destroyed all your product. So anyway, the main point is, there's a good reason for countries like Singapore to be worried about whether or not they're going to have a reliable and effectively run power grid.
Yeah,
Um,
Taiwan as well, right? They're like the leading manufacturer of silicon, or at least
well,
of superconductors.
yeah. Well, actually, I guess I don't know that part of the story. I only know little bits and pieces from the stuff that I've worked on. But yeah, I know. So Singapore has a triopoly, three firms. It's not a duopoly like we have here, but they want to know, what's going to happen. So my thing was, well, the original question I asked is like, what do we mean by game? And you said, well, okay, you can do experiments, you can see how people behave, and you can predict their behavior with the game theory. But what makes it a game? That was really the substance of my question. And why is competitive equilibrium not a game?
I would say a competitive equilibrium has more um, external factors than a duopoly or triopoly.
Oh, okay, you got to put more
Because
meat on the bone.
meat on the
That's
bone,
that's
okay.
pretty abstract. Let's be concrete. Um, so well, tell me if this makes sense to you.
Hmm.
So notice we have this MR1 is equal to MC1, right? And then we end up with this reaction function, right? And notice that we're describing um, firm one's behavior. This would be the Q1 part of it, and we haven't done it yet, but you'll see a real life example in a minute. But I'll call it Q1 star. That's not an asterisk. That's supposed to mean like its optimal quantity, right? And it's dependent explicitly on what the other firm is doing, Q2. You see that?
Yes.
And whenever that happens, we call that a situation of and this is what happens in all games, strategic interaction. That's our magic phrase. Okay. Now notice under competition, and I'll do this a little bit up here. So this is a different color. Under competition, we have this exact same thing. Okay. So the profit maximization, and again, if you go through the other lectures very carefully, you'll see me do this there too. But profit maximization also implies that the competitive firm is going to set marginal revenue equal to marginal cost, right? But the thing is, under competition, marginal revenue just ends up being equal to the market price, whatever it is. Okay. Maybe I'll put two little equal sign there. So the result is under competition, you have price is equal to marginal cost, right? And marginal cost for, let's say, firm one in the competitive industry, right, is going to be dependent only on the output of firm one. So firm one, you can get to their Q1 star, and it's only going to be a function of the market price, right? It's not going to depend explicitly on what any other firm is doing. And this is, what we call, and this is non-strategic interaction. This is the opposite of strategic interaction, is we say it's a price taking equilibrium.
Yeah, that's like pretty much exactly what I meant without the detail. That the external factors I was referring to would be like the price, because in a competitive market, no one's the price maker.
Yeah. So if by external you meant like external to
the firm,
the firm's decisions or to other firms' decisions, yeah, firms are only interacting in this very limited sense that somehow it is all being price takers. They look at the same market price and they make their decisions to produce or not to produce. But you never see something like what we're showing you right here, which is, before firm one can even begin to make a decision about output, they've got to first refer to what the other firms in the industry are doing. In this case, there are only two of them, so they're just referring to the output decisions of firm two. And that's what we call a situation of strategic interaction. So, okay. So then from there, I mean, hopefully you can see, because this is, not supposed to be difficult. I'm just trying to move things around a little bit. So we can see, but so now I have the residual marginal revenue of firm one. So I'll go ahead and write that and put it equal to the marginal cost of firm one. And we'll just run through the algebra really quickly. So I have 260 minus 7Q2 minus 14Q1 is equal to 4Q1, right? And so I'm still talking to you, Arslan. So if you see anything that looks weird to you or whatever, just let me know.
Okay.
And so here, then we can see that our reaction function is going to be Q1 is equal to, and I'll try to write it with as much detail as is needed, divided by 18, right?
Yeah.
Okay, so that's the reaction function for firm 1. We would do the same thing for firm 2. And I'll actually, let's see. Okay. Andres, are you here? Andres?
Yeah, I'm here.
Okay. So why don't you go ahead and formulate the reaction function for firm 2 based on the information we have there, okay?
Okay.
And let's see. And how about a Miles Quintana? You here, Miles?
I'm sure you mean Mike.
Oh, Michael Quintana. Sorry, your name was right.
Oh my God, this is another
Is
one.
there another Miles Quintana? Okay, okay, Michael. So you work on the reaction function for firm 2 also, okay? And then we'll come back to you and Andres. Okay, and for Michael Quintana and Andres, as soon as you get finished, just put in chat that you're done, and we can go from there. Or if you're having a hard time getting started, then let me know. Okay, Michael says he thinks he's got it. Andres, how are you doing?
Still working on it.
Okay. And does anybody else have any questions about what's going on right now as we're waiting? Hey, Steven, how are you doing?
Good of you.
Do you have any questions about this, or does it all make sense?
No, it's all pretty straightforward.
Okay, good. Okay, Andres, so how are things going with you? You said you're still working on it. Are you about finished, or did you need a little bit of help?
I should be about done almost.
Okay.
Yeah, it's pretty straightforward.
Okay. So why don't we do exactly what I did here just to make sure, and I'm gonna put a little little hat there on the Q1, so we know it's a reaction function. And so what should I write here? I have MR2 is equal to MC2. Why don't you walk me through that part of it, Andres?
Well, it's just putting marginal revenue 2, which is 260 minus 7Q1 minus 14Q2 times Q2.
Right. 7Q1 minus 14Q2. And then that should be equal to
5Q2 times
5Q2. Yeah. And so then Michael Quintana, what did you get for the reaction function for firm 2?
It's 260 minus 7Q1 divided by 19.
Okay. Okay, there we go. All right, so everybody agrees. And so now the last part of this is once we have the reaction functions, and I'll show you all quickly here. Then we find the Nash equilibrium. And okay. So once we have the reaction functions, we find the Nash equilibrium. But notice that we could actually graph these reaction functions, okay? And if we graph the reaction functions, we're gonna graph them, and usually the way that you would do it is you would label one of the axes the output for firm 1, and the other axis you would label as the output for firm 2. And then notice, Andres, do you have a calculator with you on your phone or something?
I do.
Yeah. So tell me, I'm going to do the reaction function for firm 2 first. Okay. And so notice, so 260 divided by 19, what is that?
Uh, 13.68.
Okay, 13.68. And I'm gonna, and then the slope, right, is going to be 7 divided by 19.
Yeah.
And what do you get there?
0.36.
Yeah, so it's going to be a pretty flat curve, right?
Yeah.
So I'm going to draw it like that. Now, let's see this. So we said it's 260 divided by 19. And you said that was 13 point what?
Let me check. 0.68.
0.68. Okay. Now, notice that this is saying, so firm 2's best choice of how much to produce if firm 1 was to produce nothing, right? Because the axes over here, right, they cross at 0, right? So when Q1 is 0, Q2 would produce 13.68 units, right?
Yeah.
So, and that's kind of interesting, like on its own. because if there are only two firms in the market, right, and one of them produces nothing, then the other one gets to behave like a monopolist, right?
Yeah.
So notice that in this case, the vertical intercept of the reaction function of Q2, the way that we've plotted it, should be the monopoly output for firm 2. And so we can go ahead and verify that. And again, this is good work for you all to do, because remember, ultimately what we want to do is we want to be able to compare the competitive equilibrium, the monopoly equilibrium, and the Cournot equilibrium to each other, right? So if we were going to do, and I'll put it in a different color over here. If we're going to do the monopoly equilibrium, we would be setting marginal revenue equal to marginal cost, right? But in this case, if firm 2 is the monopolist, then MC is just equal to MC2, right? And the marginal revenue, not the residual marginal revenue, but the marginal revenue for the whole market is just going to be 260 minus 7Q. And in this case, we could write 7Q2 because, well, at least that would be the demand, right? But the marginal revenue would have twice the slope, minus 14Q2, right? And then we could set that marginal revenue equal to MC2, and we get 260 minus 14Q2 is equal to 5Q2. And so then sure enough, we get when Q2, when he's acting like a monopolist, right, is going to be Q2. And again, if I was in class, I would put special labels over the variables so we could distinguish them. But I'll just put an exclamation point for the monopoly quantity, right? And sure enough, it's going to be 260, right, divided by 19. Do you see what I did, Michael and Andres?
Yeah.
Yeah. And so the 260 divided by the 19, that's exactly our intercept of our reaction function for firm 2, right?
Yeah.
And then at the other extreme, right, we can go ahead and say, well, let's just see what would happen if, when would Q2 produce nothing? And that would be our horizontal intercept, right? So we let that Q2 hat be equal to 0. And we saw for the Q1 that makes that true, then that would be our interpretation for what's happening here at the horizontal intercept for the reaction function. And so now we can draw the reaction function. Now notice when we draw the reaction function for firm 1, it's going to look a little bit different just because the axes are flipped, right? So it's easy to start with reaction function for firm 2 first. and maybe I'll put a little label on it. So I'll just, so that's the firm twos. And you'll see in the other lectures online, a lot of times I call the reacting function RF. Okay. And let's do the other one in blue. Okay, so what should I put for the horizontal intercept here for firm 2? Or excuse me, yeah, it would be the horizontal intercept, but it, you know, has the interpretation before that we gave it to the vertical intercept for firm 2. Now that the axes are being flipped, it's going to be the monopoly output for firm 1. What should that be, Michael?
I'm sorry, I was away for a minute.
Okay. So, so I'm asking for this point down here.
That's if Q2 produces 0.
No. So now we moved on to the reaction function for firm 2, the blue one, and so I'm talking about. Notice, right now we graphed that reaction function. Now we're going to graph Q1's reaction function, but to do that, we have to, right, kind of like in our minds, flip the axes, right? So we're talking about the vertical intercept for this equation. So it should be the, I don't know if you can see this, but it should be the 260 divided by 18.
Yeah, it's 14.44.
Yeah.
Oh, I thought that's what you were talking about. I wasn't sure.
Okay. So
I was still a little confused on the wordage.
Yeah. Okay. And I don't know if you noticed the pattern, but to the extent that you do, these numbers should be kind of obvious and make sense to you. See if you can walk yourself through this. So notice if we look at the reaction function for firm 1, and I'll put a little label on it too. Okay. Okay. So notice that if firm 1 behaves as the monopolist, right, that he's producing a little bit more output than firm 2. Does anybody want to explain that to me, why that makes sense? Okay.
Doesn't it have something to do with the marginal cost?
Oh, okay. So put some meat on that bone, right? What are the details? Why does it has something? Yeah, I agree with you. But what's going on there?
Because the marginal cost for each firm is different. They produce different outputs.
Yeah, and in particular, right, the marginal cost for firm 1 as compared to the marginal cost for firm 2 is what?
Lower.
Yeah. So firm 1 has a lower marginal cost. So even, right, because we know for the monopoly equilibrium, right, the monopolist is going to set marginal revenue equal to marginal cost. And so if the monopolist has a lower marginal cost, then the monopolist is going to produce more. right? So you know, firm one, because it has a lower marginal cost, even as a monopolist, in some sense, it's a more generous monopolist, right? than firm two. It produces more output. And the last thing to really pay attention to here is that where these two reaction functions cross, that's our Nash equilibrium. Okay, and I'll label it really quickly. And I'll just put this as, and by the way, remember on the exams, oftentimes I ask people to draw a graph. I've asked folks to draw this graph on, you know, our final exam. So you want to pay attention to the details, because, you know, it could be coming to an exam near you, okay? But I also want to point out one other thing, and then notice, right, with this point in this, and when we have two axes like this, like Q1, Q2, we would call that Q1, Q2 space, right? As opposed to price quantity space, we're graphing in Q1, Q2 space. Notice that they would each have a Nash equilibrium level of output that will eventually put down on our graph here. We're just not quite ready to do it too. But so this would be Q2 NE, and the one down here would be Q1 NE. And again, we don't have it yet because we haven't computed it yet. But this is where sometimes students kind of go wrong. And so I'll point out a little hazard, because you're almost finished, but you're not quite finished with this kind of problem yet, is remember, there's an industry Nash equilibrium quantity, right? And in order to get the industry Nash equilibrium, you have to recognize, okay, so now I've got two firms and they're both contributing output, right? So I have to add up the Q1 NE and the Q2 NE to get the industry level of output. And then there's also going to be a price that emerges. We call that NE also, just to be consistent. And then notice that that's going to come from our demand function, right? So I'll just put demand is going to be a function of industry output, right? So that's from our original PB equation. So is that clear? Does anybody have any questions? Because you know, we've gone through several steps here. No questions? Okay. Okay. So let's go ahead and solve this. So let's see. Okay. So Joshua, how are you doing this morning?
I've been good.
Pretty good. Okay. And I've got Michael Barbie here. How are you doing, Michael? Michael B.
I'm good, Professor.
So you see now we're on our last, well, almost our last step, which is to find our Nash equilibrium level of output for each of the firms in the duopoly. So how do you all think we move from here to the Nash equilibrium? Any suggestions? Joshua, maybe you want to
Well, I was thinking
bring,
since we're finding the equilibrium of the two graphs, we're just finding the intercept if we just set them equal to each other.
yeah, so mathematically, and what about you, Michael Barbie? What do you think?
I'd have to say the same.
Okay, so you guys want to walk me through the math of this? Right, so just to be clear, what we need to do is we need to do substitution and elimination. This is just like supply and demand, right? So I just have to, for example, take this reaction function for firm 2 and substitute it into the reaction function for firm 1, and then I'll have one equation in one unknown. Everything will be in terms of Q1. Can you see that?
Yeah.
Yeah. So Josh and Michael Barbie and everybody else, but I'll come back to you. Why don't you go ahead and work on that? Find the Nash equilibrium level of output for each of the firms in the industry, and then find the Nash equilibrium price for the industry. And I'll give you about like 5 minutes to do that. And you guys ready?
Sure.
Okay. Okay. Is everybody clear? Does anybody need any help to get started? No? Okay. Okay, I'll be back in just a minute. And Michael Barbie, do me a favor and remind me to turn back on the recording, okay? I'm gonna pause it.
Okay. Well,
Okay, see you guys in 5 minutes. Zooming the recording then. Okay, so, and oh, it should say record. Okay, yeah. I'm recording. Okay, so let me just do this really quickly. Because then we can start on a clean whiteboard. And so I'm just going to go ahead and dump the intermediate steps here. So we just have the reaction functions. And this is the sort of notation you'll see a lot of times, like in the other lectures that I do. So I'll write something like this. And okay, so and I suppose maybe the other notation's a little bit more helpful, even though it's the reaction function, just because we can concentrate on that being a Q1 and a Q2 and not some other thing. Okay, so let's go ahead and go through the steps then. So we said that we would go ahead and we would substitute in the reaction function for firm 2 into the variable or the value for Q2 in firm 1's reaction function. And so let's go ahead and do that. So, and this is the point or where I would normally, you know, distribute things. So I didn't have to worry about the rounding error issues too much. So we have 7 times, and now we get a little bit awkward because it's like, you know, fractions inside of fractions and that sort of thing. So I'll probably, so it's going to be 7 times, and then inside these like curly braces, we would have the 260 minus 7q1, and so if I make an algebra mistake, then just, you know, say something that you disagree with me, and divided by 18. So it's really that expression, and I'm sure that's what you did, Michael, right?
Nope, that's why it took me so long.
No, okay. So do you
I just
disagree
took
with
the longer
it?
route. I isolated first,
Okay.
but I don't disagree.
Okay. And what about you, Joshua?
I ended up doing it both ways, so one of my ways I did it that way.
Okay. Yeah, and you know, normally I write these things out on the board to be you know, like really careful with the algebra. It's a little bit harder here where I got to put everything in one line. But I could bring this out here and not have any trouble. And maybe that's a little bit clearer. Okay. But the main point is that you're going to be left with this equation in just terms of Q1, but you've got Q1 over here too, right? So you got to drag this stuff back across and separate it out and all that sort of thing. So you just have to do that carefully, and let's go ahead and do it. So I'm going to leave this as 260 divided by 18, and I'll leave this as 7 divided by 18, and then I'll play around with the stuff in the brackets just to hopefully make it a little bit more clear. So this one is going to be 260 divided by 19, right? And I'll have minus 7 divided by 19 times Q1. And maybe I put a little asterisk in there, and then it should all be clear, right? And so now we're starting to get to the point where we can see that we have just this constant term over here, and then you have this stuff that has Q1 in it. And I guess just to be clear about what terms we're dealing with, yeah, that's fine. Okay. And so I'm going to do a little bit more by distributing the so 260 divided by 18. I still got that term there, and then minus 7 divided by 18. Okay, and so I'm going to distribute this over the 2 terms in the curly braces. So again, I end up getting the Q1 by itself. And okay. And then notice, right, we have a -7/18 and a -7/19. And that's the part where things can go wrong pretty quickly if you miss a sign, right? So you gotta be really careful there. It obviously we're multiplying two negative numbers together, so it's going to be a positive, and then we'll get the 7/18 times the 7/19 times Q1. Okay, so now we have everything disaggregated pretty well. Everything's separated, so we can see pretty clearly. And so I'm going to move the terms with Q1 overall onto one side, and then factor out the Q1. So I would get 1 minus, right, 7/18 times 7/19, right? That would be my coefficient in front of Q1. And then it would be equal to all of the constant stuff on the other side. And so at this point in time, I would probably, be really tempted to just convert everything to decimals, so I didn't have to worry about it anymore. But we'll go ahead and just leave it because I don't have my calculator with me right now handy. And okay. All right. And so then the final solution would be our Q1 and E, right, is equal to everything we have here and I'll put it in curly braces, divided by this term here. Okay. So, and is that what you have, Joshua and Michael Barbie? Does it look right?
No, and I think you said be careful about the sign. I might have mixed it up, so I'm recalculating it right now just to see.
Yeah, okay. So yeah, this is the part where you have to be really careful, because again, if you miss a sign or something like that, then it can all fall apart pretty quickly.
Yeah, I must have missed that sign. That's what I'm thinking.
Okay. So for the first part, the constant bit at the beginning I have. So Q1NE is equal. So this first curly brace, I calculated 9.1228. So I don't know if you all verify that or not, but that's what I have. And for the second curly brace, I have 0.8567. Okay. So that gives me 10.6487. Now, so Michael, Barbie, Joshua, what do you think?
No, I think that's correct.
Yeah, me too.
Oh, okay, so you agree. That's good. Now notice that the last part of this is a lot easier because all we have to do is plug that into the reaction function for firm 2. And as long as, we've done our calculations correctly, we're in pretty good shape. So I'll let you both do Q2 NE and tell me what you think it is.
I got 9.76 for Q2NE.
Okay, 9.76. I'm waiting on you, Michael.
I got 9.76.
Okay, so you both got 9.76. Okay, so, and then obviously we have our total industry quantity, which is the sum of those two. And you all can let me know what you have. and then we have our price, right? So for the price, we just should have 260 minus 7 times our Q and E. So
Yeah, for that combined quantity, I got 20.41.
Same.
And what about for the price?
117.13.
Okay. 13. And that's dollars. Okay. So, you know, by way of comparison, right, we can see that the industry quantity is higher than what the monopoly quantity would be if either of the firms were behaving as a monopolist. And remember, we can take this monopoly quantity and we can plug that back into the demand curve to get the price that the monopolist would charge. And sure enough, it would be higher than the price that would be charged under the Cournot duopoly, right? So the only thing that would remain, and you know, this is just an illustration, but you know, we can see that our two quantities are going to be on the interior here, right? We didn't get anything greater than the monopoly quantity, which is good, right? That would make our diagram look weird. And sure enough, we have the low cost producer. Remember, that's firm one. Firm one is producing more than firm two is, even though the firms are otherwise symmetric in the sense that they have equal access, right, to the market, and they don't have any other special advantage over one another. But still, in the Nash equilibrium, the more efficient of the two firms produces more of the industry output, right? So everything's looking pretty good right now. And I don't know if you all remember, I'm just gonna go check really quickly. And I think it's this one. Okay, yeah, it's this. So I'll show you in case you don't remember from last time. This is our, you guys can see the competitive market equilibrium that we worked out last time, right? And notice the price and the quantity of output. Can you see this, Joshua?
Yeah, we can see it.
Yeah. So notice that, right, the competitive equilibrium price and the competitive market quantity is greater than the Cournot duopoly quantity, and the firms are both producing less than they would produce, are producing less in Cournot than they would be producing under competition. Okay, so that's everything that, you know, at this point in time we want to illustrate. I'll go back to the whiteboard for a minute, and I'll ask, okay, does anybody have any questions right now? Okay, and then I'll ask. So hopefully you remember. So Joshua and Michael, what's the next step? Where do we go from here?
If I'm being honest, I forgot what our goal was. I thought we were trying to find the price and then quantity.
Well, true. Okay, and what about you, Michael Barbie?
We find consumer surplus, producer surplus. And
Yeah, exactly. So remember, Joshua, you always have these two jobs, right? One is to describe the equilibrium. That's, you know, purely descriptive. In fact, I don't know if you remember these terms. They're like in every principles of economics textbook, and I try to repeat them here. But there are two pieces to our science. One is the positive, or that's another word for descriptive part of the science, which means it's just true no matter what. And then there's this normative aspect, which we always ask, which is, is this outcome good or bad for society, right? And that's welfare effects, right? That's our general heading, or efficiency, right? Economic efficiency. That's our next concern. So sure enough, like Michael Barbie was suggesting, right? We want some measure of total surplus. We want some measure of consumer surplus. We want some measure of producer surplus. And we're also going to be talking about, closely related concept of the profits. How much profit is the firm generating in this sort of setting? And a lot of times when students, get to this part, when we're talking about Cournot, there's a little bit of a disconnect. And the biggest problem is that it's not possible to really draw a diagram in the way that we did before. It is true. So are you following me, Joshua? Does this make?
Yeah.
Is it okay? This making sense now? It should always be the case that we do a descriptive analysis, we find the equilibrium, we describe it, and then we move on to the issue of welfare. And again, this is because we've shown that in Cournot there's market power, and because there's market power, we know we violated one of the assumptions of the first fundamental welfare theorem. So we know that this situation is likely not efficient. And so that's where we want to head our analysis next. So the first part of it is pretty easy, because if we want to talk about consumer surplus, well, we just look at demand, right? And we have a price that the consumers are going to pay, right? We know it's going to be $117.13 a unit. And we can pretty easily, right, go ahead and find the area that's below the demand curve and above the price the consumers pay. And that's going to correspond to a triangle. And then we can calculate the area of that triangle, and that'll be our consumer surplus, right? So okay, let me see. How about Miles? You here this morning?
Oh yeah.
Yeah, and what about you, Robert? Robert Hunter. Okay, maybe no Robert Hunter. What about you, Russell? Russell Barrett.
Yeah.
Okay, so Russell and Miles, why don't you go ahead and compute consumer surplus for us? Okay, and then let us know when you're done in the chat. And I'll say this. So Miles and Russell, if you need any help getting started, you can ask.
Yeah, what is the demand curve?
Well, see, yeah, right. Remember, we started out with demand way back here. Do you see it, Miles?
Okay.
Okay, you faded really quickly, but I'm guessing you've got it now. And what about you, Russell? Are you fine?
Yeah, I think so.
Okay. Okay, I'll just keep an eye on the chat for you guys to be finished.
I think I got it, but I'm also not too sure. I put the 117.13 into the demand equation to find the quantity at that price, just so I get the base.
That's fine, but yeah, you should have gotten this number here,
Yeah.
right? Our Nash equilibrium quantity should be, yeah, which is what you got, right?
Yeah.
Okay, good. Because that's how we found the price, was,
Yeah.
putting it in there here. So yeah, so we could put our Q industry quantity down here, which is our 20.41, right? And
Yeah, I think I got it.
okay. And then, so what's the other label that we're missing here? Because we can put it there just to be more explicit. We're just missing, right, this point up here, right?
Yeah.
The intercept.
Okay.
Yeah. Okay. So given that, and that's what you did too, Miles, right?
Yeah.
Okay. Okay. So what did you get?
I got 1,457.99.
Yeah, that's
Okay.
also what I got.
Okay. So, and remember, this is, it's funny, a lot of times we forget 1,000, what did you say, Russell?
457.
457.99.
99.
Yeah. Okay, good. So this measure, it's a number of dollars times a number of units. So it's like revenue. It's a dollar value. So just so you know, a lot of times in newspaper articles and things like that, you'll see, oh, this is they're talking about steel being imported from China and some trade dispute or whatever, and they'll say it's a $5 billion market. Well, part of that is an estimate of the consumer surplus that's generated from transacting in steel. Okay. The other part of it, because they're actually talking about like a total surplus measure, it's funny because sometimes news articles aren't super precise, and so they might just be giving you like a revenue estimate. But if they're doing a good job, they'll be giving you a measure of total surplus, which is our consumer surplus plus our producer surplus plus any tax revenues that would be raised. But just say consumer and producer surplus together. But it's an amount of dollars. But now I'll talk to you guys since we're chatting. So Russell and Miles, but can you see that the next part, like getting the producer surplus, like that's like, where do we go from here? Because there is no supply curve, right?
Yeah.
Yeah,
Do
it
you
definitely.
see? Yeah, you see the problem, Miles?
Yeah, there's no like bottom like curve.
Yeah. So, and I've had tons of students over the years like try to draw one and whatever, and every once in a while I get a really good student that comes up with a special case where for like one particular example they can identify an area, and it's and I told one student one year, I was like, listen, you came up with a special case and I think that's great, but if you can show me that it works for any, the area you identified works for any, if you can prove that to me, do some algebra and, do, like a half dozen examples and show me that it always works, then I'll give you an A in this class. And they never finished. So it's, to my knowledge, it's not possible to cleanly demonstrate an area that corresponds to producer surplus in these kinds of situations. Nevertheless, so how do we calculate it? Well, that's the next part, and so I'll tell you. So for producer surplus, what you have to do is realize that producer surplus is equal to profit, as I explained last time, plus fixed cost. So you can get the total producer surplus or the producer surplus for just one of the firms by adding up, I have a producer surplus for firm 1 plus the producer surplus for firm 2, and I can calculate the producer surplus for firm 1 by saying it's the profit that firm 1 earns plus the fixed costs of firm 1, and the producer surplus of firm 2 is equal to the profit, and this should obviously be the profit of firm 1 and the fixed costs of firm 1, firm 2 plus the fixed costs of firm 2. So here's where we have to just rely on the algebra. So notice, so for example, if we look at the producer surplus for firm 1, right, we're gonna do the profit for firm 1, which is going to be the total revenue of firm 1 minus the total costs of firm 1. So that's the profit of firm 1. So it's going to be they're going to sell it at the Nash Equilibrium price, but they're only going to sell their share of industry output. And remember, for the total costs, we're going to have the variable costs of firm 1 plus the fixed costs of firm 1. Okay. So I don't know if you all feel, so I'll ask you, from what I've written, Miles and Russell, do you feel confident now that based on the information we have, you could go forward?
Like you mean to solve produce a surplus?
Yeah.
Yeah.
Okay. So that was Miles. You feel okay. What about you, Russell?
Yeah, I think so.
Yeah, right. Because we're just going to come back here and say, oh, well, our price was 117, right? We know our for firm one, there was 10.6487 units, right? What's the one wrinkle in this whole thing? What's the like tough part, if there is a tough part?
Wait, what about the variable?
Yeah, that's the difficult part, right? So remember, we don't have anything on variable cost explicitly, but we do have the marginal costs, right, of firm one, right? Do you see where I'm going, Miles and Russell?
I believe I follow. Yeah.
Yeah. So do you remember how we get from marginal cost to variable cost? It was in the cost curve homework stuff. You're like, no, I don't really remember, but do you remember? Russell?
I'm looking through the homework right now to see if I can find it. Because off the top of my head, I don't remember.
Yeah. So I'll say it again. I said it last time, but so the marginal cost, and so do you see I'm illustrating marginal cost here? Right? Can you see my screen where I just illustrated? Yeah. So remember, for any level of output, and now we have, you know, the Nash equilibrium level of output, which we said we knew for firm one, right? So firm one's producing at Q1 NE. We said that was like 10.6 whatever units, right? Variable cost is just the area or the integral, if you want to you know, use calculus, that's fine. But the variable cost is the area beneath the marginal cost curve, right? And again, I don't know if that makes sense to you or not. So I'll put VC1, right, at Q1NE. But it's there. So does that make sense, Russell?
Yeah.
Yeah. So can you walk me through, Russell? Why do you think the relationship between marginal costs and variable costs exists the way that it does? Is there any intuition there? You're like, yeah, of course, this must be true. Or is it just like, Dr. Hunter said it was the area, so I just take that on faith?
Yeah, you said it works. So
no, okay. Remember, in college, we're supposed to be learning critical thinking, right? And I don't know, did you have, I had as an undergrad, like and it was actually one of the most fun and interesting classes that I had. I actually had a class in critical thinking that was taught out of the speech department. And you know, I can be a skeptic when it comes to, you know, communications in general, but the lady did a fabulous job. And she taught us all these like formal and informal fallacies And you know, the first one that she talked about was appeal to authority.
Yeah, I took a class like that. It was logic. That was my first year at Mount Sec, which is like 3 or 4 years ago now. But I did take another critical thinking class in the summertime, I think 2 years ago.
Yeah. So, and you know, at my age, when I was going to college back then, it was just perfect for me because, you know, I used to like, you know, punk rock music and things like that. And it's like, you know, challenge authority, like don't listen to anybody. so
Mhm.
so you know, it just kind of like boosted my confidence. It's like, you know, yeah, obviously I don't care if you have a 5 PhDs or whatever, like don't try to BS me, man. You know, there's got to be a reason that I can understand, not just because you said so. um so yeah, I encourage all of you, you know, to you know, it, have healthy skepticism, right? Don't just trust me. You could trust me that I have good intentions, but as far as the accuracy of the information, you know, always question me. So okay, you know, the only reason why I spent a little bit of time on this is because it's important. Um, so marginal cost, Russell, remember intuitively, it's the cost of producing each unit, right?
Yeah,
So and it excludes the fixed costs because it's like I got my factory, and now how much more is it going to cost me to produce? I'm paying my factory costs. How much more in materials and these other, remember what we call like variable factors of production,
Mhm.
right? How much more in electricity and labor do I have to spend to get 1 unit of output? And now that I have 1, to get a second unit of output, that's the marginal cost of the second unit, is how much additional amount of money do I have to spend
Right.
to get another unit, and then another unit, and then another unit. And so the marginal cost of each unit is the, you know, if you're going to say it really correctly, it's the additional cost of producing that unit. And so you can, you know, then see, well, variable cost is supposed to be, you know, the costs associated with variable factors of production. And so then it should be kind of obvious that, yeah, I'm just going to add up all of those, you know, additional costs for each of the units to get my total that I spent on variable costs to
Yeah,
produce
so the
however much
variable
I did.
cost directly influences the marginal.
Yeah, or the other way around, the marginal directly influences the variable. You know, we yeah, because it's like, you know, you've got fixed costs which are associated with fixed factors of production, things you cannot vary in the short run, like your factory is a good example, or maybe the cost of insurance for your factory, right?
Right.
You can't, you know, manipulate that or change that. You've got a 6-month lease, and you got to pay your factory costs even if you produce nothing. And then your variable costs are those costs associated with your variable factors of production, and those are the ones that you're going to use. And it's normally in econ, we'll just, you know, simplify and say, oh, you know, your fixed is your capital, which includes your factory machines, tools, and equipment, and your variable is your labor, because that's the major variable factor of production. You know, hire and fire people, you give them more hours if you want to produce more. But it's also, you know, variable costs are like materials in production too. So when we use the label variable costs, we're talking about how much did we spend on those, and factors of production are just inputs, right? How much did we spend on those inputs that we can vary, the inputs we can vary? And, you know, fixed factors of production are inputs like your factory and your machines, tools, and equipment that you can't, you know, change with output. I've got so many machines, whether I produce 1 unit or I produce 1,000 units, I'm stuck with those machines, at least in the short run. In the long run, obviously I could expand or I could downsize, but in the short run, I'm just stuck with that factory and that equipment, even if I don't produce anything. So those fixed inputs contribute to fixed costs, and the variable inputs contribute to variable costs. So the marginal cost, yeah, is the driver for variable costs. I produce a unit and I have my costs, my additional costs that are attributed to producing just that unit. And because it's additional costs, it's not like, one of the things I think students get a little bit confused about, and again, this is just kind of, a maturation of your understanding of economics, is that when, economists are talking about marginal costs, in some way you might think to yourself, oh, well, obviously, if I produce, a unit, whether it's the 100th unit or the first unit, that unit has to bear some costs associated with the machines that were used to produce it, or the factory, right? It has to bear some amount of fixed costs. But we don't think that way in economics. We think, okay, those machines are there no matter what. You got to pay for them no matter what. And so what are the true, variable costs? What are the additional costs that I need to produce that unit? Well, that contributes to my marginal costs. I will say one other thing: if you really get into this and you're really interested, then it is true that, for example, you can imagine, right? I'm using a machine more intensively because I'm producing more units. You see what I mean, Russell? And,
Yeah, I think so.
and because of that, I'm depreciating the machine, right? Causing damage to it. It's going to need to be repaired and stuff like that more frequently because I'm producing more units on it, right? So there is some sense in which capital depreciation becomes part of marginal cost. That's true, but that's not what we're talking about. We're not talking about, oh, I use machines more intensively, so now I have this other type of labor, which is like machine maintenance and repair labor that I have to use more of, right? That would be variable cost. But if you just think about the machine sitting idly there, and you're, either renting or leasing or paying payments on them because they're purchased, then they represent a purely fixed cost. So anyway, hopefully I've helped, build your intuition behind why marginal costs are directly related to variable costs. But can I help any more, or have I done enough damage? Miles, what do you think? Do you feel better? I can't hear you. You just popped in for a second, Miles. What about you, Russell?
No, it makes sense.
Okay. All right. So we didn't actually do the calculations, but again, this is stuff that's in the videos that are recorded. So from here, what we'll do is we'll present the Stackelberg result, which is different from the Cournot, and then move on. We can also do a couple of examples from the Ignithium homework on Cournot if you all want to next time. Just make sure you come to class with questions, and we can. I guess we'll probably do a few of those when we get started with the activity portion, but then we'll move on to the Stackelberg, unless you all have more questions. Okay. I am going to